Hello, good morning. Welcome to this session where I'm going to talk about career opportunities in space engineering. Let me introduce myself. I'm Saaj from University of Lincoln, where I'm a professor and global chair in robotic engineering. I'm with the School of Engineering at University of Lincoln. Today we are celebrating the International Women's Day, and I'm delighted to talk about my career as a space engineer and also to tell more about opportunities for aspiring engineers in the field of space engineering. Let me briefly introduce about engineering as a career before we dive into space engineering. So engineering in general, it it is to do with innovation, it is to do with invention. And the word engineering originated from the Latin word ingenium, and it means cleverness. So we engineers, we are having a very innovative mindset, and we try to develop technologies that enhance the quality of living our lives on earth. Broadly speaking, engineering has different core branches such as electrical engineering, electronic engineering, civil, mechanical, chemical, aerospace, and computer science or computer engineering. Although these are the main streams of engineering, there are various interdisciplinary and other branches of engineering. There is a long list, but it's important to know that there are different areas that one can specialize based on your choice. So, in my case, I opted to do my undergraduate degree program in electrical and electronic engineering, knowing that engineering is not just about fixing things, because this is a misconception amongst the public. People think it's about fixing or just building stuff. No, it's more about being a creative person that can design and build and operate innovative objects or materials. It could be a machine, it could be a building, it could be an aircraft, it could be a satellite, it could be a launch vehicle, it could be a robot, and the list is long. So in my case, I opted to do engineering, and I did my undergraduate degree in electrical and electronic engineering. Thereafter, I did my master's in systems and control engineering. So you can see that there are different choices for students if they are interested in an engineering career. I'll tell you more about space engineering over the next few minutes, but it's important to understand that engineering fundamentally is a profession very much like doing a medical degree or doing a degree in law. Unfortunately, in the UK, the title of an engineer is not very well protected like a doctor or a lawyer. And people tend to use the word or the title engineer in many different contexts. But in my experience, engineering is a long journey. It takes years to become a skilled engineer because your undergraduate degree itself will take you a minimum of 3 years in the UK, and in other countries it'll take 4 years to complete your first degree. And if you're interested in going for higher studies, like doing a postgraduate degree, it will take again minimum of 1 year in the UK, or in other countries it's 2 years. And further, if you go for doing a doctorate program in engineering, it takes you another minimum of 3 years. So in total, it takes 7 years as an absolute minimum to get the highest qualification in engineering, and it can be up to 9 years in many cases. So this is a long journey, and often engineers are affiliated to various professional bodies. In the UK, we work closely with the Institution of Engineering and Technology, And once you get your qualifications, you can register with the Engineering Council UK and you can become a chartered engineer. So, engineering by itself is not just about fixing things, and it is a very skilled profession. And internationally, there are other professional bodies like IEEE, which is the Institute for Electrical and Electronic Engineering. Similarly, in the US, they have the American Institute of Aeronautics and Aerospace. So there are professional bodies who are driving the engineering programs all over the world, and we engineers work very closely with various professional bodies. So this is to really give some background about engineering as a profession. And now I'm going to tell you more about some very interesting options or opportunities you would have in the space engineering. So space engineering, again, this is a very much multidisciplinary field of engineering where we work with electrical engineers, we work with electronic engineers, mechanical, mechatronics, computer. Then we work with scientists who have a background in physics, chemistry. We work with lawyers because they support us or they help us in understanding the different international space regulations. So space is very much multidisciplinary. Now, the question is, okay, you might be wondering why or how I became a space engineer. Well, this is very interesting because it all started back during my school days. I would like to thank my dad who worked for the Indian Space Research Organization. So I started learning from him more about satellites and launch vehicles. But as part of my school education, I was exposed to a range of career options in the space industry. And this is one of the reasons why I got really fascinated about becoming a space engineer. So during my school days, I also found it quite interesting or easy in a way to do or to understand mathematical problems, and I found it fun to learn mathematics. So of course, having a good background in mathematics was indeed very helpful in securing a position in engineering in a top-rated university in my country. I come from India, so I did all my studies in India, and I got my first degree or the undergraduate degree in electrical and electronic engineering, followed by my master's in control engineering. And I did my PhD from Indian Institute of Technology, where I specialized in systems and control, more looking at developing control systems for advanced or complex systems. So during my education, that is from my undergraduate period all the way to my PhD program, I was able to work on different systems, particularly looking at robotics, aerospace applications, and space applications. And during my postdoctoral degree program, which I did at different international universities in Germany and the UK, I was again able to specialize in the areas of robotics and also space engineering. So I had the opportunity to work on a range of space systems and also work on different types of robotic platforms for space-based applications as well as Earth-based applications. And in 2007, I started my academic career at the University of Surrey, and I was part of the Surrey Space Centre. So it's interesting to see how I opted to work in the academia rather than industry. So because of my interest in space engineering, I wanted to make sure that I work in the space sector. But I had the two options. One was to work in an industry sector or to work in the academia, like in the university, taking teaching as a profession. Considering that in most of the internationally leading universities, we do extensive research, not just teaching. I felt that this is a good career track for me because, on one side, my passion for teaching helped me to transfer the knowledge I have to the next generation of engineers. At the same time, I had the opportunity to research and also collaborate with industries in developing advanced solutions for space missions and also for supporting other earth-based applications of robotics. So this actually helped me to establish my profile in the academic sector or in the academia, where we collaborate with industries. Now, it was also important for me to gain some industrial experience, and therefore I was able to identify opportunities to work with Airbus and SSTL on different industrial secondment programs. So that way, I also got an experience working in the industry sector whilst spending most of my time in the academia, which was really helpful. So now I'm part of the University of Lincoln, where I head the Industrial Digitalization and Systems Intelligence Group, and we are driving a range of programs involving robotic development for both space as well as for other technology transfer applications to terrestrial systems. I'll tell you a bit more about my research activities and what we do at the University of Lincoln, and I'll try to briefly cover some of my previous research projects as well. So when I look at the research activities over the last, I would say, 10 to 15 years, I had the opportunity to focus more on robotics in the last 10 to 15 years. But prior to that, I also worked on launch vehicles. I had the opportunity to work with the Indian Space Research Organization on launches. And then I worked on various projects funded by the European Space Agency and other external sources, including various collaborators from the US. And we worked on other applications of space, such as lunar landers. We worked on various programs funded by the European Commission on planetary exploration, and other spin-out applications such as medical robotics. So although as a space engineer, I specialize in designing various solutions, including the system design, modeling, and control of space systems, I also work in other sectors where I can apply the technology, I can adapt the technology for developing innovative solutions in the medical domain, where I try to uh, apply or focus more on medical robotics. I work in the area of agri robotics, again, looking at mainly technology transfer applications from space domain to agri domain, where we are interested in looking at how some of the robotic manipulation capabilities we use for space systems can be applied for harvesting applications. We also look at technology transfer between planetary robotics and agri robotics. This is more to do with how we can develop the next generation of electric farm vehicles, mainly looking at a mobile planetary robotics and its technology transfer to agri robotics. Similarly, we are also looking at how we can apply the robotic technology, particularly the manipulation technologies, for handling of nuclear waste. And of course, these technologies can be extended for other applications, such as inspection of industrial machineries, including large and small gas turbines in the energy sector. We work on other concepts such as developing robots, exploration robots. And here, one other very interesting application is terrestrial mining, where the operating conditions are extreme, very similar to that of the planetary missions. And therefore, there is a good synergy between planetary surface exploration rovers versus what is needed in the terrestrial mining sector. So these are some of the areas I try to research on. But today I'll just very briefly give you an insight into each of these topics without diving into the details. So let me start with what we do in the field of orbital robotics. So robotics is a very known terminology, and in the space sector, we deal with two applications. One is applying robotics and artificial intelligence to planetary exploration missions, where primarily we are interested in exploring the red planet as well as moon. Now, there is another interesting framework that is called orbital robotics. Here, what we do is we look at designing satellites with robotic manipulation capabilities. So, one of my main research areas is developing future satellites with manipulation capabilities. These are robots in a sense because they can undertake tasks which are otherwise done by humans. But considering that anything in the Earth's orbit is an extreme condition, obviously we can't have astronauts doing all these dangerous jobs. Therefore, we are developing robotics, automation, and AI based technologies for supporting missions where we can, say, provide maintenance operation to an existing satellite which is approaching its end of life cycle. We can use such robots for repairing, refueling, or other form of maintenance of other satellites. We can use these satellites for undertaking manufacturing operations in orbit. We can use these satellites or with the robotic manipulation capabilities for building structures in space, very much like the International Space Station. One other mission scenario that I'm interested or I'm working on is the potential of robotic manipulators for undertaking large scale assembly operations in space, particularly looking at how we can design modular large aperture space telescopes with apertures more than 25 meters. Now, why do we need such complex or big structures in space? Interestingly, if you look at the Hubble Space Telescope and the James Webb Space Telescope, these are small compared to the large scale missions that we are working on. We need larger apertures for finding or for gathering more astronomical data. And we also can use such high precision space telescopes for monitoring the Earth. So there are different applications for such high value assets orbiting in space. And we can also use a robotic spacecraft for undertaking cleaning of the space debris because there is a growing concern of space debris, and in order to make sure we have or we use space responsibly, it's also important to make sure that we engineers develop technologies for cleaning up of the space to clean up all the debris we have created in space. So we are working on mission concepts where we are developing satellites with robotic manipulation capabilities for capturing of debris. The idea is to capture a debris, which could be a cooperative debris or a non-cooperative debris, and deorbit it and bring it back to Earth. And of course, these satellites or the space robots will continue to offer further service to other operating spacecraft or undertaking additional space debris removals. So there are numerous applications of space robots for orbital missions, and this is one of the areas we specialize. Another very interesting research topic is developing the technology for future planetary robots. Here, my interest is more driven by nature, where we look at bio-inspired solutions. So in a way, I can say that these are unconventional designs of planetary robots. If you look at all the previous successful missions from NASA, very evidently, the rovers that have landed on Mars, including the latest Perseverance rover, they are using wheeled chassis. In other words, wheel locomotion has a space heritage now. They have been successfully proven and tested in space. Whereas the concepts you see on the screen, like the walking robot or the hybrid wheel-like robots, these are quite innovative. They have been developed for various Earth-based applications. They haven't been at flown to Moon or Mars, but we are developing these technologies for future Mars missions or lunar missions where we can have multiple robots working in collaborative fashion to gather more science data. The reason why walking robot or the hybrid wheel-like concepts are more promising than large conventional wheel vehicles is that these unconventional locomotion systems are better at navigating through craters or crevasses, which are often challenging for wheeled vehicles to traverse. So, for these reasons, there is a large scale activity on looking at innovative design of rovers for planetary exploration missions. I'm going to run a very short video that will show you the potential of these hybrid designs. For example, the hybrid wheel-leg rover that we have developed as part of a European Union funded program will show you how a scouting rover can help in protecting a large rover or a mother rover by exploring the terrain advance of time, and relying back that information in terms of any hidden hazards which the primary rover or the mother rover can avoid. So watch this video, which is very short.
A novel concept taken through the stages of prototype, design, fabrication, and analysis focuses on two rovers working in tandem and the communication between them. Project Faster advances the mission in a number of ways. To protect the primary rover from potentially hazardous terrain conditions, it is conceived that a smaller, more robust scout rover can scope out conditions ahead of the primary rover. The scout rover is capable of traversing both rocky terrain and soft surfaces through a hybrid wheel system.
Right. Interestingly, we have a 30-minute long video on this project in YouTube. If you search for EU Faster program, you can see watch more videos on this. So let's move on from planetary robotics to another interesting area, which is to look at how we can use robots or space robots for mining of asteroids. Mining is a big business on Earth, especially for precious metals. So it's a case with asteroid mining because of the presence of rare metals, which are very expensive. But unfortunately, as of today, we don't have the technology for mining an asteroid and bringing back the samples back to Earth. So one other area that we are trying to specialize is in the field of asteroid mining, where we want to develop robots that can collect samples from an asteroid and support the sample return missions. So here, the concept we are developing jointly with my colleagues at University of Surrey and Abbas is to design a self-reconfigurable undulating grasper, which is a robot which is modular in nature, and it is very different to the traditional robotic arms that you might have seen being used in the automobile industry and range of other applications on Earth. Here, the concept is inspired by a Python. The reason I say that is this is based on the principle of creating a virtual caging around the target. At the same time, we don't want to crush our target very much like how a python would strangle its prey. Rather, we want to have a soft touch. We want to gently enclose the target prior to capturing it. The reason why this concept is more promising compared to a traditional robot arm with a rigid gripper is very much like if you try to capture a housefly, say for example, using a chopstick, it's going to be really hard, right? And in an asteroid environment, because of the low gravity conditions, it's extremely hard to collect any samples from the asteroid using a traditional robotic arm. And this is why the principle that drives Snug Robot is more promising because it can gently get around its target or the samples, and then it can collect the sample, which can then be transferred back to the earth using other vehicles. So this is another concept that we are developing with our partners. Moving from space engineering to other domains of robotics. So here it's very interesting to see that whatever technology we develop for space robotics, most of these technologies can be applied for a range of applications on Earth. I learned this through various consultations with clinical colleagues who work in the medical sector who are using robots for their surgical procedures. So when it comes to medical robotics, here again, there is an interesting story, because the robots that I have worked on, these are again unconventional robots. You wouldn't see these robots yet in an operation theater, because what is currently used in the hospitals is the very popular Da Vinci robot from NTT Surgicals, which are pretty large, rigid robotic arms. What we do is more to do with flexible robotic arms, and these flexible or soft robotic arms are inspired by nature. In fact, the project that I was part of, the STIFLAW project funded by the European Commission, this was again a design inspired by octopus. And here, this is very similar to the way the octopus moves its tentacle. We are able to navigate and control this flexible soft robot for a range of clinical applications. So as part of this project, we were able to work with various clinicians who are specializing in robotic surgery. And we were able to undertake both ex vivo testing as well as testing on human cadavers jointly with the University of Dundee. So this is another interesting example where some of the technologies that I developed for controlling a space robotic manipulator was eventually applied in the context of a medical robot or a surgical robot. And of course, the big transition or the shift is from rigid robotics to flexible robotics. And these flexible robots are becoming more and more popular. And there is a large community called the soft robotics community internationally who is driving the research in soft robotics. And I'm glad to be part of that group, looking into the future potential of soft robotics for a range of clinical applications. Being part of University of Lincoln, I couldn't stay away from stepping in to the agri-robotics research field. Here again, I found it quite interesting because my background in designing planetary robots, I found it quite useful in understanding how farming vehicles operate. Of course, in this farming sector or in the agricultural sector, we deal with larger, much larger vehicles than what we are developing for planetary surface exploration. But it is very interesting to understand the potential of farming vehicles or agricultural robots. And one of the areas I'm now supporting at the University of Lincoln is looking at how we can develop future tractors or future agri-robots that are fully electrically driven. So we are looking at the shift from hydraulically driven large tractors to electrically driven agri robots. So these are not manually driven vehicles. These are autonomous vehicles which will have some induced intelligence using AI techniques. And as part of a current project that we are part of, we are looking at how some of the technologies developed by our project partner for motor vehicles or the sporting industry can be applied to the agricultural vehicles. And this is another interesting ongoing project where we are hoping to demonstrate how an electrically driven agri robot can be used for weeding applications. So this is another interesting application of agri robots. Again, my interest and enthusiasm is directly coming from my experience from designing planetary robotics. Another very interesting research activity going on at University of Lincoln is the nuclear robotics. Many of my colleagues are working in the nuclear industry where they are developing intelligent robots that can be used for decommissioning of the nuclear power plants, the older ones. And also we are developing technologies for supporting how to handle nuclear waste, because these are extremely hazardous to human operators. And therefore, we are developing the robotics technology for remote handling of nuclear waste. And again, we are working with on a new project in collaboration with industries, looking at how we can develop robotics and automation capabilities to sort and segregate nuclear waste. So this is a new project that we kicked off just a few days back. When it comes to engineering as a profession, I must say that it is very exciting because you do get the opportunity to work not only with people in the academic sector or academic community, but also with industries, and you do have great opportunities to collaborate internationally. This is because we work on several internationally funded research projects, and we get the opportunity as space engineers, we get the opportunity to work with international space agencies such as the European Space Agency, NASA, JAXA, and so forth. And we also have the opportunity to attend numerous conferences where we present our research findings. We listen to other researchers about the clever things they develop. And it is also a great forum for networking and building up your contacts. So as an engineer, I would say that working in the academia, we do get the opportunity to travel worldwide to attend various research forums, conferences, and events where we can learn and we can also share our research findings. So I think if I would like to say a few words summarizing my career as a space engineer, I would like to say that this profession is very exciting because we always work on challenging projects. When it comes to research, we are looking for more and more innovative solutions. So in that sense, it is equally adventurous. You never work on the same thing. You keep changing, because you always work on new ideas, new concepts, and you end up developing new systems. So in that sense, it is equally exciting and also adventurous. But considering that this is a profession that needs more dedication, this is a profession that needs skills. I can say that from my experience working in the space sector for the last 25 years, it has been a very, very rewarding journey. Interestingly, today we are celebrating the International Women's Day, and I'm also celebrating my Silver Jubilee in space engineering. And I have been in the space sector for the last 25 years. So I believe we engineers have a big role in shaping the society. and we engineers make things happen. So I'm really proud to be an engineer, and I encourage more younger generations to step in to this industry, particularly the space industry, if you have a passion for space. So with that, I would like to conclude my talk, and I'm very happy to take up any questions from the audience. If you have any questions, feel free to put your questions in the comment box, and I can take it up from the comment box. Okay, thank you. Thank you. So I welcome the participants to flag up any questions through the comments box. I can see there are a few questions. Let me see if I can take them up one by one. Okay, one of the questions is, which is the most interesting development in space engineering emerging this year? Okay, so this year, definitely it is the successful launch of NASA's Perseverance rover. So I think that's the most exciting thing we have as of today in 2021. But we are also equally looking forward to the launch of European Space Agency's ExoMars rover. So this is another planetary or the rover mission to the Mars. And there are various other upcoming missions. And hopefully over the next, I would say, 5 years, we'll see more successful stories from the space. Okay, I'm waiting for more questions. Feel free to jump in. Okay, the next interesting question is, will we get people to Mars in 25 years? Very likely, I would say. The reason is, internationally, there is a big push towards manned missions, although robotic missions will be the precursor to any manned mission. So there is a huge interest in returning back to the moon, and so is the case with exploring the potential of human settlement on Mars. So this is something, obviously, technologies or the time will prove. But in 25 years, I'm very confident that there will be more and more missions, successful missions to the moon and Mars. And hopefully, we will also see some manned missions, although we cannot guarantee with space missions because space missions often takes decades to develop and evolve. So it's much harder than other Earth-based programs. I'm very keen to take up more questions. That's why I kept my lecture short, so that I can answer questions from the public. And maybe a few other things, just to fill the time, I can share is about UK space programs and UK space robotic programs. So we are working very closely with the UK Space Agency and UK-based space companies to drive UK's national space robotics programs. So we are very, again, confident that over the next 5 to 10 years time frame, we will see some interesting robotic missions to low Earth orbit and other high Earth orbit, where there might be some opportunities to work on orbital robotic missions, mainly looking at active debris removal, cleaning up of the space, and looking at how we can create structures or infrastructure in space, which can be used for scientific research. There is another question. Is there any PhD positions in the area of space robotics in my group? Yes, absolutely. We do have opportunities. And I would encourage you to have a look at the Lincoln Center for Autonomous Systems and also our university webpage, where you can look for opportunities. So whenever we have a funded position, we advertise the post. So this includes both PhDs as well as research positions, research assistant, research associate, postdoctoral research associate, and so forth. So there are different opportunities. Have a look at our webpage for more opportunities. It's difficult because I can't see you, and the only mode of communication between us is this chat box. So I'm watching the chat box for more questions from the audience. And in the UK, again, coming from India, my initial experience was that, well, engineering is not very popular as a career in the UK. Which is, of course, now changing. Over the last 20 years, I have been very active in school outreach programs, and people are realizing that engineering is not just about becoming an electrician or doing some sort of fixing pipe work, etc. This is a more skilled profession. You have to undergo training for minimum of 7 years if you want to complete, or if you want to get the highest qualification, that is a doctorate in engineering. But as an absolute minimum, even an undergraduate degree program in the UK will take 3 years, where you get the opportunity to work on projects. And if you also go on an industry placement, that is 1 year at an industry, you complete your first degree in 4 years with 1 year industry placement. So this is a very skilled profession, I would say. And if you, whether you work in the academia or whether you work in the industry, there are plenty of opportunities for engineers, not only in the space sector, but there are numerous other sectors where we need more and more skilled engineers. Right, I can't see any more questions, so I presume all of you followed me very well. But feel free to drop in your questions, or you can also contact me via email if there are any further questions. Okay, there is another question on space robotics projects. Do you use machine learning? Yeah, for capturing space objects. Yes, we use machine learning techniques because for any mission on space debris, that is, if you're looking at space debris or equally capturing a satellite for servicing or maintenance operation, we rely on vision-based sensors as well as LiDARs and other sensor suite. And because these targets are unpredictable in many cases, we use AI-based techniques for developing or inducing intelligence into the space robot so that it can navigate, it can rendezvous and talk with the target safely, and carry out the necessary work. So machine learning is a very popular technique that is very widely used in the space missions, not only for robotics, but also for other space missions. Again, if there is anyone in the audience who is interested in learning more about space opportunities in space, you're very welcome to contact me. And we do offer various forms of mentoring support. Again, this is not only limited to students, but also to other people who are interested in opportunities in the space sector. Okay, that's interesting. And maybe I could also add a few other things about like training opportunities, because as part of various engineering programs offered in University of Lincoln and also in other UK universities, they do provide the provision of going on a year abroad or going on a industry placement year, because this is something really useful for students, because if they get the chance to work in an internationally leading organization where they can be part of a research project, or say work in an industry setting, which is very different to working in the academia, they return back with a lot of hands-on skills. And for this reason, I always encourage my students to go on an industry placement or year abroad, where you get that international exposure or an industry experience, which is very valuable when you graduate and start hunting for jobs. So this is something I always encourage students to consider, because all forms of skill sets are really valuable when it comes to doing actual work. Okay, if there are no further questions, maybe we can wrap up this session. But as I said, feel free to drop me an email anytime. And you can also look for other opportunities in our web pages. Okay. So with that, I think we could wrap up. Because I can't see you, it's very hard to decide. But looking at the flow of questions, it looks like audience are happy. And for that reason, I say goodbye for now.